Hey everybody, thanks for joining in. What we're going to talk about today is probably something that is, on the minds of many people around here. We're going to talk about LLMs and observability together, which is probably, a very interesting topic for a lot of you guys moving into Bedrock, using OpenAI, using Anthropic, using whatever, and we're going to focus on how we do it right. So let's start with why LLM observability even matters, right? I think that probably 99% of you guys use LLM to some form. But why does observability and kind of monitoring them, why does it matter? We started, just maybe a couple of years ago with like simple flows of, an agent or a model that I query, get a response, everything was simple. And now we have a ton of complication, right? Multi-turn agents, multiple steps with, different functionalities, kind of using different agents, different models to get into a final outcome. We have retrieval pipelines, right? Like RUG, that enrich, that embed, that create a data pipeline up to the actual model at the end. Any silent failure on any of these will screw up the entire process, right? We have tool augmentation. Our workflows now use scripts and APIs and different stuff that basically kind of comprehends the entire workflow of what we're trying to do. Something goes wrong, something is high latency, and the entire workflow suddenly doesn't work, right? Now, you want to observe a lot of different things that you're already thinking about if you're using LLMs today, right? The most common things we hear about is token usage, right? All of these pricing models are connected somehow to token usage, to kind of on-demand capacity that you're querying. 1 million tokens of context, it just keeps growing, right? You want to monitor that. You want to know how much your users are using, and you have no control of that because eventually your developers are the ones that are making a choice of how many tokens is being inputted and outputted, right? Response latency. AI has got into production quicker than we would imagine, right? The value was so high that we just rushed it to production. It eventually, your APIs depends on it today, right? If you're serving a customer-facing API or using AI in the middle, any latency there can impact, hundreds of % of your latency suddenly just because you wanted that value. Same for error rates, right? If a model suddenly replies with an error, which happens due to structure issues, due to anything that can happen, and you don't know about it, your API can suddenly go wrong. Before it was all a box you can control on, now it's getting more complex. And the fourth thing, and maybe the most sensitive one, is LLM responses, right? How do I detect hallucinations? How do I know that the response is even correct? Any of you that tried to query an LLM 50 times for the same thing got 50 different results, right? And eventually we want to figure out how to kind of monitor and figure out what's going on. Now the challenges are that the speed in which your stack is changing has never been as fast as now, right? We've implemented AI into production, skipping security, skipping privacy, skipping anything in your companies to get value into production and into your customers, right? And anything that kind of prohibited that value was put aside. But right now, you're introducing a new tool every month, right? From Cloud code to anything that is creating even code into your production to actual AI used in your workflows to get value to your customers, right? The rate in which this is changing is higher than the rate that you can observe, instrument your code, instrument your application to even track and monitor what you're doing. I'm sure that 50% of the companies here are not even sure what models you're using right now in production just because of the pace things are changing and things are examined. The second thing is the sensitivity of data. AI eventually creates a very interesting situation where user input can be incredibly sensitive, right? It can be not even something that depends on you. What happens if your application exposes a chatbot to your end user? They can input a very sensitive information about their customers, about themselves, that you might never wanted in your application, but now you can control, and now you're responsible for. So who gets to upload what? Where the data goes? Who stores it? Which third party am I relying on? That's a big part of the challenges around LLM observability. Groundcover does things very different around observability in general, but it has a lot to do with how people should think about LLM. Most of the audience that is currently using Bedrock, for example, with AWS, has similar concerns. The first thing that Groundcover does differently is that we use a bring your own cloud architecture. Basically, instead of being a simple SaaS model where we store the data of all the monitoring, telemetry that you send out and present it to you, we deploy and manage an observability backend on your cloud premises in your AWS account. It's fully managed, it's fully hands-off like a SaaS experience, but you get the value of data privacy, data residency, and full control of what's being stored without us processing it, storing it, or removing it from your environment. We also use eBPF, which we're going to talk about in a second, which is a kernel level visibility to instrument your application at the speed you write them in, right? If you introduce a Bedrock application tomorrow, it's instantly instrumented with eBPF without you doing anything. And again, the pace in which things are moving is higher than what you can predict. Those two combined, the data collection with eBPF and bring your own cloud to store it cost effectively and private, is what allows us also to build on experiences which are high granularity, which we'll show in a second, of how LLM observability can actually look like. So what is eBPF? eBPF is basically a kernel level capability, kind of a superpower that allows us to look into what APIs and microservices are doing without you instrumenting code. With LLMs and AI, it gets even more important, right? You can literally cover your production now, any AI involved, without modifying your applications, without even redeploying production, without adding an SDK into your code, which again, you want to get to value of AI quickly, you don't want to do it, right? Second, we get kernel level visibility. We can actually capture the full API requests and responses, their actual payload. So we can see the prompts, we can see the responses, we can see what's actually being transmitted, so you get the visibility to figure out what's happening. And we can translate that to real-time insights, because suddenly you have access to token usage, to reasoning path, to LLM calls and error rates, to actually correlate them to logs, metrics, traces collected outside of your environment, right? Outside of that LLM application. And the bring your own cloud piece is basically what allows us to do it so securely and privately. Basically what it means is that we've found the balance between a managed service and an on-prem deployment. We separate the control plane and the data plane. So the data plane that you can see on the left is basically being hosted in a sub-account in your AWS environment. But the control plane that manages the infrastructure, scales it, updates it, provides the SLA that you deserve from an observability company, is being run by groundcover on our side. We have no access to your data. We don't store it. We don't process it. You don't have to rely on us for security and privacy of your GDPR sensitive and very kind of business critical data. That allows us to do a few interesting things. First is protect LLM pipelines from data exposure, right? You can now capture very sensitive data on what your users are doing with your AI without worrying that this data will be trucked or shipped anywhere. All this data has been stored in your premises with groundcover, and there's no third-party storage, no outbound communication, no egress of this data to anywhere that you need to be concerned about. The second is that you can actually use this to improve performance and manage spend, which is, again, with all the value of AI, this is becoming a critical issue that everybody wants to take a look at, right? You can look at token usage, latency, throughputs. We're going to see example of error rates and things that we're going to dive deep into the demo in a second. And the third and most important thing, you can actually monitor LLM responses with the context that allows you to do something with it, right? Maybe I want to look at response payload. I want to see which tools the LLM used or chose to use in the actual application. I want to see history of path that the LLM chose to eventually do stuff, and I want to figure out what variance is my users getting from my deployed AI, right? What's actually working and what's not. All of this can be deployed in minutes. Install the sensor. It has an auto-discovery. You don't have to tell it that you're just instrumented Bedrock into your application. It will auto-detect it, and suddenly you will see Bedrock APIs going out of your microservices, and they will be monitored and correlated to all the other insights that you collect, like log management, infrastructure monitoring, and all the things you're used to seeing. Jumping into a quick demo, just to kind of show you how that might look like. Sorry about that. So with groundcover, basically, the first thing that you're going to see is all of your deployments and what's running inside the cluster. You can also see a dependency map of who's communicating to who. In this case, specifically, I can say filter Bedrock and see shop service, which is a regular microservice running on my Kubernetes cluster, communicating with the Bedrock service through Bedrock traces that I can actually observe. The second thing that we can look at is actually see our API calls. In this case, focus on Bedrock. I can see which models I'm using in general, what's the latency, what's the throughput, how many of these being used. Just to emphasize, anything that you're seeing here, you didn't do anything to get. The eBPF sensor just collects it once you deploy a daemon set on your EKS cluster, and you're good to go. AI information and context is being collected immediately. Let's look at a cool example. This is the traces screen ground cover. Basically, the eBPF sensor will collect any trace that flows through the system. We can focus, for example, on anything that is Bedrock related. I want to see what's flowing through the cluster. And I can immediately see flows that are even wider than Bedrock. In this specific example, I can see a service map of a client communicating to another service, and then I can see Bedrock being executed in the middle at some point, right, where AI needs to be involved. The cool thing about it is that I can actually see the full eBPF context of what's happening. I can see the request model that you use, the response model, the tokens that are being used. I can see the chat, right? I can see the prompt and the response from the server. I can see the raw request in case I want to figure out exactly what was transmitted. And I can even see correlation to things that you care about, like logs, right? In this case, shop service was telling me that it's about to create an AI greeting. In this case, it created some kind of greeting with the AI service, and I can correlate it with the logs and even with the infrastructure monitoring tool. So how much is that AI being called from in front of Bedrock? What is the actual latency? What is the CPU of the container? Anything that I want to take a look at. And all this was correlated at the edge by the eBPF sensor without you thinking about it, instrumenting, notifying the sensor what to take a look at, right? Because eventually you're moving really quick. The other thing we can look at is errors, right? In this case, this is an example of a Bedrock Anthropic model that failed. And I can see the actual prompt and the response, so that in this case indicates of kind of IAM problem that I couldn't eventually use the relevant model or kind of approach the relevant Bedrock service. Troubleshooting that without observability would require someone from the DevOps to figure out what's going on. In this case, a developer that is experimenting and trying to deploy this to production can now see what's going on. Another interesting example that we can take a look at is basically trying to explore this data in ways that can help you build kind of business context on top of that. We can take a look at our traces, and in this case, for example, take a look at P90 latency of any model that we use. So in this case, I can actually take a look over a specific period of time. I can look at which models are the high latency models that I want to take a look at, right? In this case, Anthropic is one of the high latency ones. There's a few faster ones that are maybe operating better. Now I can correlate that with token usage. I can correlate that with value, with specific APIs that trigger these models, and I can make decisions, right? I can also do the same for token usage, right? I can suddenly take a look at any token usage that I have inside the platform and say, you know what, I want to figure out what is the actual usage of tokens across my different models. And I'll make decisions about, should I really use this model? Is this equivalent to the quota that I was expecting? What is my team doing? What are they building, right? So I can figure out what's going on. We can also do more sophisticated stuff that will eventually allow us to dive into areas where we care about for actual SLA in front of our customers. Say that I'm using Bedrock, but I also want to figure out anything that is of duration above 1 second, right? Because that's the SLA that I promise my customers. Any API that crosses 1 second kind of affects my SLA that I guarantee to my customers. First of all, I can see the actual traces that causes this. I can actually take a look at an example, in this case, a 1.4 second response from Bedrock, and I can see, okay, what's going on? What's the actual flow, but also what's the prompt that triggered that? What's the context? Why is it taking so long? The second thing that I can do is drill down on this specific filter and figure out if there's anything I should care about. Is there any model that is taking care of that? Is there any specific token usage that might be triggering that specific latency? Am I seeing that high latency only on like very big prompts, very big contexts, or very specific workflows? That is very valuable. Just getting into this data and correlating it and figuring out what's going on, that's really hard. I can also take a look at the relevant workloads, right? Who eventually is the service that is responsible for any of these? What's creating these queries inside my specific environment? The second thing I could do is set alerts, right? Now that you have all this data and you care about SLA, and you know that if this specific SLA is breached, you want to know, why not just create a monitor of that you can now use to alert your teams and alert yourself that something is going on. So in this specific case, if there's an LLM SLA breach, right, I might want to know. Every time that it crosses 1 second, I want to get notified. And look how easy that was without you doing anything, because the traces were there, the context were there, and now you could just need to define the business value of what you care about. Anything that revolves around that can now be created into dashboards, right? The things that are repetitive, that you should care about for a longer period of time, that you want to even share with your customers, that you want people to be aware of when you're using AI. Which models and vendors am I using? What's the latency? How is token usage behaving over time? Am I crossing my quota? Am I in a good state? How is latency behaving over time, and who to blame? Which models am I using? Have I introduced a new model? Is something kind of moving around? Is it related to a version that I want to focus on? Anything that we've seen so far can basically be baked into monitors, dashboards, and things that can be repetitively used to dive into what you're looking at. Baking that into the context of your production, your dependency map, who's communicating with who, is what eventually can drive the information, the value that you need to your business. Going back a bit to kind of the start where we were, all of this is basically achieved with a very innovative approach to how we monitor AI, right? If up until now you had to instrument an SDK into your code, pick and choose what you want to monitor, right? I've instrumented the new AI applications into my code. I now need to instrument the functions using it and notify my SDK, my OpenTelemetry SDK, or whatever I'm using. I need to notify that this is important for me while my developers are running forward. Now I can deploy an eBPF sensor and get the value immediately. If before I had to redeploy production or test things at staging and dev, now production is running and it's covered in 30 seconds from deployment. And also I can store logs, metrics, and traces in the same environment under my Bring Your Own Cloud, not worry about data residency, not worry about privacy, not worry about data security, and not worry about creating a new sub-processor that might concern my customers and get all this value. Thank you for listening. If there's any follow-up questions, first of all, you can find us in the yellow shirt booth right over there. Can't miss us. I'll be right over here for any questions or follow-ups that come up. We have a playground that you can check out at play.groundcover.com, where you can see all this demo and play with it yourselves. I'm sure that it will kind of give way to new questions, so feel free to try it out. We have a free tier, and we're over there, and just happy to answer any questions. Thank you for the time.